Assalamu alaikum. Today we are going to solve October-November 2024 9709 42 mechanics paper, and without wasting any minute, let's move forward. Uh, this is the first question, question number 1. The velocity of a particle moving in a straight line at time t seconds after leaving a fixed point O is v meter per second. The diagram shows a velocity time graph which models the motion of the particle from t0 to tt. The graph consists of 4 straight line segments. The particle accelerates from rest to a speed of v meter per second. So here the speed is 0 meter per second, and after 4 seconds the speed is now v meter per second, and then decelerates at 5 meter per second squared to instantaneous rest. So from here, in this portion of the journey, the object is decelerating, which means that the acceleration is minus 5 by 3 meter per second square, or the gradient of this graph from basically 4 comma v to 10 comma 0, it is minus 5 by 3 meter per second square, because a gradient of a velocity time graph is acceleration. Over a period of 6 seconds, the particle then travels back towards O, reaching a maximum speed of 3 meter per second, which means that it is moving in the okay, before coming to rest at time t is equals to t seconds. Okay, find the value of v. So how can we find out v? We can use the gradient that is given to us, the acceleration that is known. So simply the acceleration is basically the gradient for the speed time graph. So the acceleration, we already have the coordinates. Let me write down the coordinates over here. 4 comma v and the other is 10 comma 0. The acceleration value is minus 5 by 3, which will be equal to 0 minus v divided by 10 minus 4. So it will be minus 30 is equal to minus 3v. So if we simplify, the value of v will be 10 meter per second. This is the velocity when the time is 4 seconds. The B part says that given that the total distance traveled by the particle from 0 to t seconds is 68 meters, find the value of t. So the total distance that is traveled from 0 up till the last and t, it is 68, and find the value of t. So distance of if you want to find out distance from a speed time graph, that is basically the area under the graph. So in this scenario, there are 2 areas under the graph. First is from 0 till 10, and the other is another triangle from 10 till t seconds. So we'll add the 2 areas together, and that will be equal to 68. So 68 will be equal to 1 by 2 times base, which is 10, the height, which is v, that is also 10, plus this is the area of the first triangle, plus the area of the second triangle is 1 by 2 into base, the base of the triangle, this portion, the length of this portion is t minus 10. The distance between the two values is t minus 10. So let's substitute it as t minus 10 multiply by the height is 3. So we just need to simplify. It will be 50. So 68 minus 50 will be equal to 3 by 2 bracket t minus 10. So it will be 18 times 2 divided by 3 is equal to t minus 10. So it's 12 plus 10, which will be the value of t, and the value of t is 22. Okay, let's move to the next question. Question number t is 22 seconds. Question number 2. Question number 2 says that a block of mass 20 kg is held at rest. So the mass is given to you, which is 10 kg, and it is held at rest. It means that the value of u is 0 meter per second. At the top of an inclined plane inclined at 30 degree to the horizontal. Let's make a shape first, visualize it first. So the shape looks like this, with this angle is 30 degrees. Here is the block at the top, and he says that he says that is projected with a speed 5 meter per second down a line of greatest slope. So this block is going to come down in this direction, and the speed of the block with which it is going to move will be 5 meter per second. There is a resistance force acting on the block. So the resistance force is going to be backward, which will be this Fr, because the block is moving down. As the block moves 2 meter down the plane, so the block has moved 2 meter down, which means that the block is right here, and it has covered a distance of 2 meters from its point of projection. The work done against the resistance force is 50 joules. So what do we need to find out? We need to find out the speed of the block when it has moved 2 meter down the plane. Okay, we know the mass of the block. So mass, let's resolve the mass as well. So mass will be 20 times 10, which is 200. That's the weight. We have to resolve the weight into the two components, the x component and the y component. This angle will be 30, and this value will be 200 cos 30 degrees, and this will be 200 sine 30 degrees. Now he says we have the work done against resistance, work done against resistance is known to you, which is 50 joules. So using this work done, and we are aware that work done is equal to force multiplied by distance covered in the direction of the force, and we are aware that how much distance is being covered, and we are aware of the work done. We can find out the resistive force. So the resistive force will be 25 Newton. Now, since the object is in motion, we know that object is in motion, so we will apply forward minus backward is equal to MA. Now we know which forces are moving in the forward direction, since the object is coming down. So this yellow force is going to have a forward impact, while the backward force will be the resistive force. So forward is 200 sine 30 minus backward is 25. The mass is 20, and we can find the acceleration from here. So 200 sine 30 minus 25, which is 75, divided by 20 is equal to acceleration. So the acceleration will be 3.75 meter per second square. Now this is the acceleration that we have, but we are supposed to find out the speed of the block when it has covered a distance of 2 meters. Now further, we know that the distance that the object has covered, v square minus u square equals to 2as. We need to find out the final speed. The final speed is v square. The initial speed with which the object or the block was released was 5 meter per second. So 5 square minus 2 times the acceleration is 3.75 into the distance covered in the direction is 2. So if I simplify, v square will be equal to 2 times 3.75 into 2 plus 25. So it's 40. So v will be equal to square root of 40, which is 6.32 meter per second square. Meter per second, sorry. So this is the speed. Find the speed. Okay, now let's move to the next question. Question number 3. Question number 3 says that a cyclist is riding along a straight horizontal road. Let's visualize it first. That he says that there is a cyclist on a horizontal road, and the total mass of the cyclist and his bicycle is 90 kg. Mass is 90 kg. The power exerted by the cyclist is 250 watts. The power is 250 watts. At an instant when the cyclist is moving with the speed of 5 meter per second, his acceleration is 0.1 meter per second square. Find the value of the constant resistance to motion on the cyclist. Since the cyclist is moving in this direction, we need to find out the resistive force. The resistive force is definitely gonna move in the opposite direction. Constant resistance we need to find out. So basically we need to first find the driving force. Using that driving force we can find out the resistive force. Now how can we find out the driving force? We already have the power. We know the formula. Power is equals to force into velocity. The power is 250 and the driving force we need to calculate, and the speed by which it is moving is 5. So if we simplify, the driving force is going to be 50 Newton. So this is the driving force. This is the forward force in this case. So forward, since the object is in motion, so what we will do, forward minus backward is equal to MA. So forward is 50, backward is the resistance, and mass is how much? 90 kg, and the acceleration is 0.1. So it will be FR, which will be 50 minus 9, 41 Newton will be the resistive force. Okay, let's move to the next part. B part says the cyclist comes to the bottom of an inclined hill at 2 degree to the horizontal. Now let's visualize. There is a hill, and the angle that the hill is making with the horizontal, it is 2 degree, and this is like this. Given that the power and the resistance to the motion are unchanged, so power is the same, the power was, what was the power? 250 Newton, watt, sorry. And he says that the resistance is unchanged, so frictional resistance is unchanged, which is 41 Newton. Find the steady speed. Steady speed means that the acceleration will be 0. Steady speed, which the cyclist could maintain when the riding up the hill. So now, since the cyclist is moving up the hill, so this is going to be the driving force, this is going to be the resistance, and we also have to resolve the components of the weight. This is the weight, and that's the weight is 90 kg. Yes, 90 kg. So no, mass is 90 kg, so 900 is the weight, and this is going to be 2 degrees, so this is going to be 900 sine 2, and this will be 900 cos 2. Now, since the object is in motion, so we know that we will use forward minus backwards is equal to MA. So forward is the driving force minus the backward is the frictional, which is the same as 41, but there is one more frictional component, that is this component of the weight, which is 900 sine 2 equals to, mass is how much? 90. The acceleration is 0 because it is going to move with the steady speed, so the acceleration value will be 0. And we know that the driving force formula can be driving force can be calculated from power and the speed with which it's moving. So driving force will be equal to power divided by the speed. So power is 250 divided by speed that we are supposed to find out, minus 400. Let's take everything to the other side. So it will become 41 plus 900 sine 2, because 90 times 0 will be 0. So 41 plus 900 sine 2, it will be 72.4095. 250 divided by V. We can calculate the value for V. 250 divided by this will be 3.45 meter per second. So this is the steady speed with which the object is moving. Question number 4. Question number 4 says the diagram shows two particles A and B of masses 0.2 kg and 0.1 kg respectively. The particles are suspended below a horizontal ceiling by two strings AP and BQ attached to fixed points P and Q on the ceiling. The particles are connected by horizontal string AB, which is making an angle of 45, and the other side it's theta. Each string is light and inextensible. The particles are at equilibrium. So this is another keyword, which means that the particles are at rest. So for the rest thing, it means that the upward components and will be equal to the down components, and right and left will be equal, which means that the sum of the horizontal components will be 0, and similarly vertical components sum will also be 0. So what we can do is, let's resolve first. We know that the tension in the string, this is going to be this direction, and similarly in this string the tension is going to be towards away from the point of observation. Similarly, the tension in this string is going to be TAB, and this is going to also be the tension away from the point of observation, TAB. whose value is going to be same for both of them. Now let's resolve the tension in AP string. So if we resolve it, it's going to be direction like this. It's tension AP, so let me write it as tension AP, and it will be sine 45. Similarly, this is going to be tension AP cos 45. I have to resolve the other side as well, the other string component as well. Let me mark it as TBQ. The resolved part for this is going to be TBQ sine theta, and this will be TBQ cos theta. This is all that I have. Yes, I also have the weight. The weight for A will be 2 Newton, and the weight for this is going to be 1 Newton. Now we know that the upwards and the downward forces are going to be equal. Now let's do it for A only first, and then we'll go for the B. For A, now for A we know that upwards and downward forces are going to be equal. So TAP will be equal to TAP sine 45 will be equal to the downward component, which is 2 Newton. So if we solve it, tension in the AP string will be 2 divided by sine 45, which will be 2.828 Newton. This is the tension in the AP string. But we are not interested in the tension in the AP string. We are supposed to find out the tension in the AB string. Now let's resolve for the AB. So horizontal components are also going to be equal. The horizontal components acting on particle A is TAB, which is acting to the right side. It will be equal to TAP cos 45. Now we already have the value of the tension in string AP, which is 2.82. We will multiply it with cos 45. Multiply by cos 45. It will be 2 Newton. Tension in the string AB will be 2 Newton. Let's move to the next part. Part B. Part B says find the value of theta and the tension in the string BQ. So we need to find out theta and we need to find out the tension BQ. That's very simple. We'll apply the same methodology that the particle B is in equilibrium. Up will be equal to down and the right will be equal to left. So let's apply T. Okay. So up equals to down, TBQ is equals to, so it will be T, let me write up is equals to down. Why? Because it's in equilibrium. So T and TBQ sine theta, it will be equal to 1. This is the first equation that we have made, and right equals to left, and the right is TBQ cos theta. Right TBQ cos theta, it will be equal to TAB. It will be equal to TAB, and the value of TAB is already found out in the previous part as 2 Newton. So TBQ will cos theta will be equal to 2. So we can simplify TBQ will be equal to 2 divided by cos theta. This is one equation for TBQ. and the other equation for TBQ can be TBQ equals 1 divided by sine theta. Now we know that the tension for TBQ string is going to be same in both of them. We can equate them together. So TBQ will be equal to TBQ 1 divided by sine theta will be equal to 2 divided by cos theta. Now we will bring it to this side. It will be sine theta over cos theta will be equal to 1 divided by 2. So tan theta will be equal to 1 divided by 2, and the value of theta will be tan inverse of 0.5, which is 26.6 degrees. So it's 26.6 degrees. That's the theta we calculated. We need to find out the tension as well. For tension, we will just simply put it in this formula. For tension, we'll apply the theta over here in the above formula. So tension in the string BQ will be 2 divided by cos 26.6. So 2 divided by cos this, it will be 2.24 Newton. That's the tension in the string BQ. Okay, let's move to the next question. Question number 5. Question number 5 says that the two particles P and Q of masses 2 m kg and m kg respectively are held at rest in a same vertical line. So, and the height of P and Q above the horizontal ground are 1 meters and 2 meters respectively. So it means that the particle P is closer to the horizontal ground. P is projected vertically upward with a speed of 2 meters per second. At the same instant, Q is released from rest. So let's just visualize it a little. So let me make a diagram. This is the horizontal ground, and on the horizontal ground the particle P is more close and the particle Q is somewhere a little far. The distance of the particle P from the ground is 1 meter. And he also says that the distance of the particle Q from the ground is 2 meters. So it means that the distance between P and Q is 1 meter. And he also mentions that the object P is being released upwards. P is moving upwards and the speed by which it is moving is 2 meters per second. And he also says that Q is released from rest at the same minute. Q is being released at 0 meter per second for at the same time, and find the speed of each particle immediately before collides. So for example, this is the place where the particles are going to collide. So we know that this is somewhere not in the mid, definitely, because one particle is already having a speed of 2 meters per second, the other is at 0 meter per second. So it is going to be different. The distance from this particle from the place where the P particle is actually to the place where it collides, let me mark it as x. So the distance of the Q particle from the place it collides will be 1 minus x, because the total distance between the two particles is 1 meters. So what we can do is, let's apply the formula. Distance is equals to ut plus half at square, and we will apply this formula on both of them. We'll apply on particle P, and we are going to apply the same formula on particle Q as well. I'll tell you in a while that why are we applying the same formula on both of them. The distance that the object P has traveled till the collision point is x, and the speed with which it's moving, it's 2 times t plus half, and the acceleration, since it's moving upwards, vertically upwards, so it's minus 10 into t square. Similarly, if I talk about q, let's simplify it first. So it will be x equals to 2t minus 5t square. This is the equation that we have made for the distance that the particle p has traveled. Now for the particle q, the distance that the particle q has traveled is 1 minus x. The speed by which it has started its journey is 0. So 0 times t plus 1 by 2, the acceleration is 10. Why? Because it's coming down, vertically downwards, into the time, which is t square. So if I simplify 5t square, so 1 minus x will be equal to 5t square. Now if I simplify and make the x subject over here, it will be 1 minus 5t square equals to x. This is the second equation that I have made in terms of x. Since x will be equal to x, let's substitute to find the time at which they are going to collide. So it will be 2t minus 5t square equals to 1 minus 5t square. Like terms collect, so it will be 2t minus 5t square plus 5t square equals to 1. They will cancel out, and the value for t will be 1 by 2 seconds. So after 1 by 2 seconds, they are going to collide each other. So now, but we are not interested in finding the time after which they are going to collide, but we are interested in finding the speed of each particle before they are about to collide. So let's find out the speed for both of them. So for p first, let's find for p, and then we'll figure it out for q. Now for particle p, we need to find out the final speed. So for final speed, we are going to use v is equals to u plus at. So we need to find out the value of v. The value of u is 2. The acceleration by which it is moving is minus 10, and the time that it has taken is 1 by 2. So if I simplify, the value of the speed is minus 3 meter per second. Similarly, if I talk about, it's negative because it's going upwards. So if I talk about the other one, the q, v is equals to u plus at. So u is 0 in this case. The value of a is 10, and the time is still the same, which is 1 by 2 seconds, half seconds, and the speed by which it is going to collide, about to collide, it will be 5 meter per second. This is the end of this part. Let's move to the next B part. The B part says that it is given that immediately before collision, the downward speed of q is 3.5 meter per second. Okay, but before that, okay, so before that, let's calculate the distance that the object has traveled. The object has traveled, x is equals to 2t minus 5t square. This is for p. This is for p. X is equals to 2t minus 5t square. So 2 into 1 by 2 minus 5 into 1 by 2t square. So if I simplify, it will be 5 into 0.25. 1 minus answer, it will be the value of x will be minus 0.25 meters. So this is the distance traveled by p, and the distance traveled by q will be 1 minus 0.25, which is going to be 0.75 meters. Now, but the question says that it's about collision, and the speeds, initial speeds are known to us, the final speed is given to us, and we need to find out the final speed of the particle p when it is about to hit the ground. So we know that momentum is conserved So momentum before is equals to momentum after. So momentum before, let me write the formula, mp up plus mq uq equals mp vp plus mp vq. Now he says that the mass of the particle p is 2m and m. So it will be 2m, and the speed with initially with it is moving, it is, we just found out, that is 3, plus the mass of the particle q is m, and the speed by which it is moving is 5 initially before the collision, and now we'll talk about after collision. So mass is still 2m, velocity we need to find out, the speed we need to find out. The mass of the particle q, this is particle q, it's m, and the speed of the particle q before after the collision is 3.5. Now it's 6m plus 5m equals 2m vp plus 3.5 m. M, it's 11, m equals, m is common on this side, 2 vp plus 3.5. M and m will cancel out. 11 minus 3.5 equals to 2 vp, and vp will be 11 minus 3.5 divided by 2. 11 minus 3.5 divided by 2. That is the speed before it hits the ground. So it's 3.75 meter per second. So this is the speed, instant speed that it reaches the ground, the particle p. Now let's move to the question 6. Question 6 says, a particle p travels in a straight line starting from a point O with the velocity of 6 meter per second. The acceleration of p at a time t seconds after leaving O is this. From 0 to 1 seconds the acceleration is different, and from when the time is greater than 1 the acceleration is different. He says that find the velocity of p when time is 1 second. So we have the acceleration equation, so we are going to go one step backwards to find the velocity. So velocity equation will be the minus 1.5 integration of, since it says equal to 1, so we are going to use the equation up. So it will be integration of t power 1 by 2 dt. So it will be minus 1.5 t power 3 by 2 divided by 3 by 2, which is 1.5, and since there are no limits we are going to put a constant c. 1.5 and 1.5 will cancel out, and we will have a minus t power 3 by 2 plus c, which is for c for the velocity. But in the question he says that the velocity is 6 meter per second when it is about to start, when it's starting. So we know that v is 6 when time is 0. So if we substitute it here, 6 is equal to 0 plus c, and the value of c will be 6. Now he says that find the velocity. So velocity will be equal to minus t power 3 by 2 plus 6. This is the equation for velocity. Now we just need to substitute the time here, and if I substitute minus bracket 1 power 3 by 2 plus 6, the velocity is 5 meter per second. Next part, given that there is no change in the velocity of p when time is 1 second, find an expression for the velocity of p for t greater than 1. So it's very simple. Now he's doing the same thing for the next part of the journey. So v will be equal to integration, let me 1.5 integration 1. It's t to the power 1/2 minus integration of, let me take the 3 out, 3 t power minus 1/2 dt. If I do the integration, it will be 1.5 t power 3/2 divided by 1.5 minus 3 t power 1/2 divided by 0.5 plus c. Now 3 divided by 0.5, which is going to make it 6. Yeah, 3. Okay. Yes, so it will become, this will cancel out, t power 3/2 minus 6 t power 1/2 plus c, which is the equation for v. Now but we need to find out the value for c. He has told us in the question that there is no change in the velocity. So v is 5 when time is 1. So let's substitute. It will be 5 equals 1 minus 6 plus c. It will be minus 5 equals 5 plus c. The value of c will be 10. So find an expression. So the expression is velocity equals t power 3/2 minus 6 t power 1/2 plus 10. Okay, now let's move to the next part. Next part says, given that the velocity of p is positive for t less than 4, find the total distance traveled by between t is equals to 0 and t is equals to t is equals to 4. So we know that the total distance, there are two portions of the graph. So for finding out the total distance, we are supposed to integrate. The first portion is from 0 to 1, and the velocity formula for the first portion is this minus t power 3/2 plus 6 minus t power 3/2 plus 6 dt, plus for the other portion it's from starting from 1 until 4 time. This is the equation that we have for velocity. So and this is dt. Now let's do the integration. It will be 3/2 plus 1, which will be 5/2, and it will become minus 5/2 t power 5/2 plus 6t, and the limits are from 0 to 1 plus. Now we are going to apply integration of this as well, and it will be 3 plus, it will be 2/5, because 1 divided by 5/2 will be 2/5 t power 5/2 minus 6, it will be t power 3/2. So 6 divided by 3/2, which is 1.5, is 4 plus 10t, and the limits are going to be 4 and 1. Let's substitute the limits, because in the first one, if I substitute minus 2/5 t plus 6, it is going to be 28/5 This is the upper limit minus the lower limit is 0 plus, now let's substitute 4 over here in the next. Okay, 4 power 2.5 multiplied by 2 by 5, this is going to be 64 over 5 minus 4 power 1.5 into 4 minus 32 plus 40. This is the upper limit. Now minus the lower limit. For the lower limit it will be 2 by 5 plus 4 plus 10, and this is the lower limit. So it will be 28 by 5 plus 64 by 5 minus 32 plus 40, which is 104 over 5 minus 2 by 5 plus 14, which is it's plus 10. It's 32 by 5. Now if I further simplify, 104 divided by 5 minus answer, so it is 28 over 5 plus 72 over 5. So 28 plus 72 is 100. So 100 divided by 5, the answer of the total distance is 20 meters. Okay, let's move to the next question. Question number 7. And okay, question number 7 says two particles A and B of masses 0.2 kg and 0.3 kg respectively are attached to the ends of a light inextensible string. The string passes over a small fixed smooth pulley which is attached to the bottom of a rough inclined plane at an angle of theta, okay, where sine theta is equal to 0.6. So sine theta, it means sine theta is basically 6 by 10, which is basically 3 by 5. So if this is 6 by 10, it will be 4 by 5 using the right angle theorem. Particle A lies on the plane and particle B hangs vertically below the pulley 0.25 meters above the horizontal ground. The string between A and the pulley is parallel to the line of greatest slope. The coefficient of friction between the particle A and the plane is 1.125. This is the value for mu. Okay, particle A is released from rest. So the initially it was at rest. Find the tension in the string. So we need to find out the tension in the string and the magnitude of the particles. Okay, now what we need to do is we need to resolve first of all the particle A. The weight the weight component we need to resolve for A. The weight is 2 Newton. So the two components for weight are going to be like this. This is going to be theta, which is theta. So this portion is going to be 2 cos theta and this will be 2 sin theta. The object is the tension in the string is going to be away towards this side. No, it's going to be the opposite way, na? The pulley towards the pulley, na? It's going to be this way, and since the object is going to go down and so the direction is also going to be this, and the frictional component is going to be the opposite, which will be Fr. The normal reaction is going to be like this, R, and the tension over here in the string will be this. So but there is the weight that is left, the weight of the particle B will be 3 newtons. Okay, that's all we have. We know we will apply the things because the object is in motion, so we'll apply forward minus backward is equals to ma on particle A. So let's apply for A. So we'll apply forward minus backwards is equal to ma. The forward force is the tension. That's not just the only forward force, but the component of the weight, which is 2 sine theta, that is also acting in the forward direction. So 2 sine theta. The backward force is the resistance, and the mass is 0.2 kg. So 0.2 multiplied by the acceleration, that is unknown. In place of friction, we can write down mu r. So let's substitute the values. 2 times the value of sine theta is 3 by 5 minus mu. We need to still find the value of r. R will be equal to 2 cos theta. Upward component will be equal to the downward component. So 2 cos theta. 2 times cos theta is how much? 4 by 5, which is 8 by 5. This is the value for r. Let's substitute. We know the mu value already, which is 1.125. Multiply by 8 over 5 is equals to 0.2a. So this will be t plus 6 over 5 minus 1.125 multiplied by 8 over 5, which is 9 over 5 is equals to 0.2a. So it will be t minus 3 over 5 is equals to 0.2a. We can make t the subject, which will make it 0.2a plus 3 over 5. Okay, now we'll do the same for particle B as well. Now let's do it here for B. Its upward is equals to downwards. Since the object is moving downwards, so forward is going to be 3. 3 minus t is equals to mass is 0.3 kg into the acceleration. So if we make the subject, it will be 3 minus 0.3a, which will be equal to t. Now let's substitute these t equal to each other. 0.2a plus 3 over 5 is equal to 3 minus 0.3a. So it will be 0.5a, which will be 3 minus 3 over 5. So 3 minus 3 over 5, which will be 2.4. So 0.5a is equals to 2.4, and the acceleration will be 4.8 meter per second square. We were not supposed to just find the acceleration, but the tension in the string as well. So for the tension, we can just substitute it in any of the above formula. So let's substitute in the second, which is t is equals to 3 minus 0.3a. So 3 minus 0.3 bracket 4.8. So 3 minus 0.3 into 4.8, which is 1.56 Newton. Tension is 1.56 Newton. Now the next part says that when B reaches the ground, it comes to rest. So after some time, the B particle, this particle, when it comes over here, this particle comes to rest. Okay. Find the total distance that A has traveled down the plane from when it is released until it comes to rest. You may assume that A does not reach the pulley. So basically what is happening, this is the horizontal ground, this is the pulley, and the particle A is traveling from here, this side, and when this B particle reaches the ground here, we basically need to find out the total distance that A has traveled. This A particle, how much, for example this is A, how much distance the particle A has traveled. So what we are gonna do is, we know that time is 0 when this is 0, and this is basically happening at A. We'll first of all look for A, and what we can do is, we know that the object A is in motion, so forward minus backward is equals to MA. The forward force, basically we are assuming that the tension in the string is 0, na? So forward minus backward, the tension component over here in this formula becomes 0. So tension is 0, so the other component forward is going to be 2 sine theta, which will be 2 times, let me write it here, 2 sine theta minus the backward component is the friction, which is 9 by 5, is equals to MA, which is 0.2 times the acceleration. Now since the acceleration is going to be different because there is no tension, and the sine theta value is known to you, which is 3 by 5. 3 by 5 is equals to minus 9 by 5 is equals to 0.2a. So it's going to be minus 3 over 5 is equals to 0.2a. The value of the acceleration is going to be minus 3 divided by 5 into 0.2. So minus 3 over 5 into 0.2, which is minus 3. So the acceleration will be minus 3 meter per second square. Now when the particle, when B reaches the ground, when B reaches the ground, we know that the speed of the particle B we need to calculate, and it will be equals to u square plus 2as. Particle B was initially at rest, so 0 square plus 2 times acceleration is, the acceleration of the particle B is how much? It's 4.8. It's 4.8, and the distance that the object has covered is 0.25. 0.25. So VB square, 2 into 4.8 into 0.25, which is 2.4, and the value, the speed by which, with which it is going to reach the ground will be square root of 2.4, and that will be 1.55 meter per second. This is the speed by which it is going to reach the ground. And this now the at A, we can find out how much distance the object A has traveled with the same speed. So it will be this particle A is going to be at rest in the final moments, and the speed by which it is going to start will be u square. U square will be the same speed with which the object B is going to end. So it will be 2 times the acceleration is minus 3, and the distance is s. So minus 2.4 is equals to minus 6s. This will cancel out, so 2.4 divided by 6, which is 0.4. So the additional distance that the object A has traveled is 0.4. So the total distance that the object A is basically 0.25 plus 0.4, so it will be 0.65 meters. This is the total distance that the particle A has traveled when the object B has reached the ground. That was the end of the paper. I hope you have understood all the questions. If there is any question, any ambiguity, please leave it in the comment section. I'll try my best to answer it at the earliest, and wish you all the very best. And if there is any video, any paper that you would like me to solve before your paper, please let me know in the comment section. Please share it with your friends so that it can help them, as well as it can help me to grow my channel. Thank you so much. Allah Hafiz.